Alright, so this is a pretty cool problem. In fact, this is so cool my cat is sitting on my lap while I go through this problem because she's pretty interested in sulfuric acid. Okay, so we got some 98% by mass sulfuric acid, and we're assuming it's aqueous, so the other thing is water. And we're asked to calculate the molality and molarity, and in order to figure out the molarity, we're going to need to know the density of the solution. So what do we mean when we say it's 98% by mass? That means that basically we've got 98 grams of our H2SO4 and 100 grams of the solution. So presumably the other 2 grams then are H2O. So which one's the solute and which one's the solvent? So we said in class that the smaller component was the solute and the greater component was the solvent. But here I'm going to switch and I'm going to go ahead and assume that since we're interested in not the water, but the sulfuric acid, then it makes more sense to think of the sulfuric acid as the solute and the H2O as the solvent. Because, I mean, after all, we never use this solution to deliver water. We only use it when we're delivering H2SO4. So it makes sense that that's our solute. So what's the molal concentration? Well, the definition then is it's the number of moles of what we're calling the solute over the number of kilograms of the solvent. And the number of kilograms of the solvent, I think we can get that pretty straightforwardly. So we know there's 1,000 grams in a kilogram, and so converting involves dividing by 1,000, which is shifting the decimal place 3 times over. And so we've got 0.0020 kilograms of solvent. So in order to figure this out, all we need to know is the number of moles of solute. How can we figure that out? Well, we've got 98 grams of sulfuric acid. So let's take sulfuric acid and learn how to convert grams into moles. And you probably remember doing a lot of this in the first semester. And so what we do is we just multiply the atomic weights by the number of atoms. Sulfur is the only one that is not commonly used in these problems, but hydrogen and oxygen and carbon we use an awful lot. You probably have that committed to memory. I get 98.08, and so if you like, that's the number of grams there are in a mole of sulfuric acid. So if we have 98 grams of sulfuric acid, you can see we've almost got a mole, and we can go ahead and we can do the conversion using what we've got above. You can see that's going to be slightly more than what we have on the top, so we'll have slightly less than 1 mole. And if you run the numbers, you get 0.999 moles of H2SO4. So that means that our molar concentration is just the number of moles of solute, which we decided was sulfuric acid, divided by the number of kilograms of our solvent, which we decided was probably water. And so when you do that division, you get a pretty large number, right? You get 499.6 moles per kilogram. And in terms of significant figures, we should probably stop there at the second one. So that would be sort of 499.6, so that would be basically 500 moles per kilogram. And the underline notation, where we underline the last significant figure, is one of those things that I think is sort of a chemical slang, and so probably best not to use it unless everyone else agrees they're going to use it, but we can write it using scientific notation. So 5.0 times 10 to the 2 moles per kilogram would probably be the best way to do it. All right, so what about molal? Oh, I'm sorry, we've already done that. What about molar concentration? And so molar concentration is the number of moles of solute, which we have from above. That's the 0.999 over the number of liters of solution. And so at least the top part here we already have. So the question is, how many liters of solution do we have? Well, you know what, we took 100 grams of our solution above, and since concentrations are intensive, it really doesn't matter how much we take. And we've got the density in the problem, and the density is 1.83 grams per mil. So that means that we can use density as a conversion factor. In fact, since there is 1.83 grams in 1 milliliter, then we can go ahead and we can just convert that. And again, you're going to see that's going to be about half the initial value, so that's 54.6 milliliters. Or if you remember, there's 1,000 milliliters in the liter. Dividing by 1,000 is shifting the decimal 3 places over. We can get the number of liters by just basically putting a couple of extra zeros in front. So now the molar concentration is the number of moles, which we calculated above, over the number of liters. And it's going to be a pretty large number, right? I get 18.3 moles per liter, or of course 18.3 capital M. And that's sort of one of those numbers that all chemists know. And that is to say, if you've got concentrated sulfuric acid, that is about 18 molar. If you've got concentrated nitric acid, that's 15 moles per liter. And our friend concentrated hydrochloric acid is 12 molar. So that's a number that's worth keeping in your chemical toolkit.